The first two tables, a pressure table and a temperature table, are used only for wet steam and dry steam. If the steam is superheated, you do not use any of these two tables. Now we're scrolling down for the third one. The third table is called a superheated steam table or water table. Superheated. This is for superheated steam. That is table A6. You only use this table if you are dealing with superheated steam. Remember, there are three types of steams that you are dealing with. It is wet steam, it is dry steam, it is superheated steam. So for superheated steam, this is the table that you use. For wet and dry steam, you use the pressure table and the temperature table. Very, very important. Now let's start with the first one, the temperature table. We are going to start with the first one. Let's look at the properties that we have here. This table shows all the properties that we spoke about last week. The first one, you can see that the first column here, it is the temperature in degrees Celsius. The temperature in degrees Celsius followed by Pz. Pz stands for saturated pressure. Pz is saturated pressure. So the first column is the temperature and saturated pressure. And then next we have what we call the specific volume of liquid. Vf, remember I said F, that subscript F stands for liquid or for water. So Vf is the specific volume of water or liquid. Next is Vg. Vg is the specific volume of a dry vapor or saturated vapor. Dry vapor, saturated is the same thing. Vg is a dry or saturated vapor. Specific volume. Now, we are not going to be dealing with internal energy for now. Maybe we can skip this one, but I can still explain, it's fine. But I don't think there's a point in which we are going to be using internal energy. But in any case, UF is the specific internal energy of liquid. UFG, specific internal energy of evaporation. In other words, we're dealing with a vapor. A vapor is wet and dry steam. Wet, sorry, is a mixture of liquid and vapor. G, specific internal energy of, let me increase the font here. Yes, I think the font is good now. The font is good. So now the most important ones is the specific volumes, or I can say from here to there, from temperature up to the specific volumes, enthalpy and entropy. These are the most important ones for now, or for this term. Next year you are going to use the entire table. Now we have HF. HF is the specific enthalpy of liquid or of water. HF. HFG is the specific enthalpy of evaporation. In other words, vapor and steam and water. And then Hg, specific enthalpy of dry steam or saturated steam. And then the last column is entropy. SF is the specific entropy of liquid, followed by specific entropy of evaporation, and the last one is the specific entropy of dry steam or saturated steam. Now, can you see that on this table there's no superheated steam, there's no soup. Everything here is G, Fg, and F. Is liquid, is vapor, and is wet steam. So this is the table. You can see that the first value that you see on that temperature table is 0.01, the temperature, and the pressure is 0.6117. And this reminds us of what we did last week. Last week we said that a triple point of water, the temperature is 0.01 degrees and the pressure is 0.6117. So the first digits or numbers, these are for the triple point of water. Remember last week we discussed, we said that A triple point of water is a point at which all the three phases are in equilibrium and coexist, where you have liquid, solid, and gas in equilibrium. So here are the temperature and the pressure properties of water. When you are dealing with another fluid, the temperature won't be 0.01, of course, and the temperature won't be 0.6117, of course. But now we are dealing with water. This is what we have. So now we scroll down. Okay, by the way, the units are also very important. Because the specific volume is cubic meters per kilogram. Internal energy, kilojoules per kilogram. And the enthalpy, kilojoules, both of them are energy. Enthalpy and internal energy are energy, so the units are the same. And then the entropy, kilojoules per kilogram Kelvin. So from here we scroll down. We scroll down until where? Until the end of this table. At the end of temperature table, you have the temperature is 373.95 and the pressure is 22 megapascal. What is this? This is the critical point of water. Remember last week we defined what the critical point is. So the coordinates, not the coordinates, the properties of water, as in temperature and the pressure, critical point is 373 and 22 megapascal. So you can see that they are here. You can see that here is 373 and 22. This is the critical points of water. Again, if you are dealing with a different or another fluid or liquid, this is going to change. It won't be 373 or 22 megapascals. Now we move on to the pressure table. The pressure table, now you can see now we start with pressure in kPa, followed by Tz. Tz is the saturated or saturation temperature in degrees Celsius. Now it follows the very same things that we had in the first table, where we had a specific volume, internal energy, enthalpy, and entropy. Now you scroll down up to 100, 101.325. This is atmospheric pressure at sea level. You don't just say it's atmospheric pressure. You have to keep reference that this 101.325 is atmospheric pressure at sea level. And from there, you can see that at sea level, water boils at 99. This is the actual value. Normally, we say that water boils at 100 degrees Celsius, but the actual value here, according to the table, is that at sea level, water boils at 100 degrees Celsius. The actual value here is 99.97. Okay, so this is a boiling point for water at sea level. We saw the critical point of water. We also saw what? The triple point of water. So this table actually is a continuation of what we learned last week. And then we scroll down up until we are done. And the last values, or the last value, the two last values here under pressure table, it is the critical values again. The critical pressure is 22 megapascals, and the critical temperature of water is 373. So now we are done with wet steam and dry steam. We are moving on to the superheated steam, table A6. Sorry. Now you can see now that even the orientation, or the way the table is arranged, is different from the first ones. Remember when we dealt with a molar diagram last week, I said above the saturation line is superheated steam because of pressure and temperature, and below is going to be dryness fraction and the pressure. So because we are doing superheated steam, we had temperature. Here is the temperature. Now let's say, for example, we say that we are looking for the enthalpy of superheated steam at 300 degrees Celsius. And the pressure, because remember, for you to get any of these values here, you need two properties in order to get the third one. So the properties that we have here is temperature, specific volume, specific internal energy, specific enthalpy, specific entropy. So for you to get something here, you need a property, you need to have two properties in order to get the third one. So in this case here, I will say that the pressure is, let's say, is 10 kPa. 10 kPa. And then the temperature is 300 degrees Celsius. I don't know why my gadget now is not working. 300 degrees Celsius. So the question says calculate or determine the enthalpy. So in this case here, the temperature here is 300. Here is 300. And then the pressure is 10 kPa, 0.10 kPa. So you draw a line under 300 and the corresponding enthalpy here. So your answer here is 3076. 3076. I don't know why my device is, I'm really having problems with this thing. So at 10 kPa, the steam is superheated at 10 kPa, the temperature is 300 degrees Celsius, the corresponding enthalpy is 3076.7, and the corresponding entropy S sub. This is H sub. This is S sub. This is V sub. T sub, V sub, U sub, H sub, and S sub. So everything here is superheated. The question is the pressure. Let's see the enthalpy at 1 megapascal and 300. 1 megapascal and 300, scroll down, we are looking for 1 megapascal pressure. Here is 1 megapascal. This is where we are. This is 1 megapascal. And then we said that the temperature is 300. And the corresponding enthalpy here is 3051.6. So that's how you use the superheated testing tables. In order to get any of this, you need at least two properties. If you have temperature, there's no pressure, you won't get any of the properties you're looking for. Okay.